Hi everybody, this is Dakota Potts here from potsprecision.com. For those of you who don't know, I did attend school for gunsmithing and have a couple technical degrees from the Piedmont Technical College School of Classical Gunsmithing, and as well I studied machine tool technology. I have an associate's degree in that, and I've done a fair amount of professional work both with guns and manufacturing and in machining, both medical and aerospace, and a few other, odd job type shops. So I just wanted to go over some of the measuring tools that a gunsmith / light machinist would use to be successful. Now remember, gunsmithing includes as a practice modifying and making new parts. So unlike someone who is, say, an armorer, a gunsmith needs to have the capability more so to identify and dimension parts and make new ones or modify other parts to fit. So the most basic tool, I think, for measuring is a dial caliper. A dial caliper typically measures from 0 to 6 inches and reads the output on this dial right here. So as I open up the jaws of the caliper, you can see the dial goes around and spins, and you look towards the shaft of the caliper to see your first digit, meaning if this is reading out in thousandths of an inch, you're going to be reading the tenths of an inch here, so 100,000, 200 thousandths, something like that. So these are very quick and easy to use. Honestly, even somebody who's not manufacturing parts should have a caliper laying around. If you need to take a measurement off of something, you just throw it on there, and I can see that that is just a couple thousandths shy of 700 thousandths of an inch. See if... So it's a little difficult to focus, but the point of this video isn't necessarily to walk through how to use all of these tools and read them. I can do something a little more in-depth on that. But it just gives you an idea. With this, you can easily throw your calipers on any item that you need to measure and just get a general idea very quickly. So we have, how long did I make this cutoff barrel? So 5.287 inches. So just under 5.3 inches. And that's the advantage of the dial calipers. They're light, they're handy, you get a quick readout. They are not necessarily the most precise instruments. So most shops where I worked, the tools had to be certified because of ISO and other manufacturing processes. And calipers of any kind typically would not be certified for more than, depending on the shop, 3 thousandths of an inch or 5 thousandths of an inch. And that's plus or minus. So meaning if you have something that requires a stricter tolerance than being within plus or minus 3 thousandths of an inch, the calipers would not be certified for that use. Part of the reason being it's pretty easy to fake them a little bit. So depending how hard I push, again, I'm going to see if the camera can pick up on this at all, but depending how hard I push, I can change the measurement of this to 2.5 thousandths pretty easy just by pushing on the thumb wheel. A dial caliper like this one is an RCBS branded that I bought from Brownells, I think, for something like $30 or $40. I'll see if I can put a link to that. That'll be good. That'll work for most things that you need to do. My advice is if you're going to buy cheap, meaning under $100 or so for a caliper, don't buy digital. I've been disappointed by every digital caliper I've bought in that price range. They break, the batteries go out, they start reading really weird, they get just a little bit of oil in them, they get dropped once and you can never use them again. Digital calipers have some great advantages. You can switch easily from standard to metric measurement. You can do, for instance, if you have one measurement where you want to say a length and you want to check a shoulder distance off of the length, instead of having to do the math, you can open it up to the first measurement, zero it, move it to the second, and read out the distance between the two. So the digital calipers are really cool. Mitutoyo makes some really good ones. I think they're actually a 0 to 8 inch, which is useful, but they're much more expensive because they're more hardened, they're more accurate, and they're coolant proof, which is really important in a machine shop environment. So next you have your outside dial micrometer. So the micrometer is a more precise instrument, and you'll see a lot of people open them up this way and close them up this way, rolling it on your arm. It's because they can be a little sensitive to force at either end. For instance, if you were to close this and then crank down on it, what you've got in here is a 40 TPI thread, which is how it divides your measurement into 25 thousandths per rotation. So if you gall up that thread or anything like that, you're gonna really mess with these. These are considered precision instruments. So with a good micrometer, depending on the quality, you can expect anywhere from bidirectional 1,000th tolerance, meaning you can accurately detect within plus or minus 1,000th, all the way down to 2 to 5 10,000ths of an inch, which is very, very precise. That's like a tenth of the thickness of a sheet of paper, roughly. So these are good precision instruments. In the context of machining, for instance, I machined this out of one piece of steel. So if I were going to machine this and maybe these dimensions weren't so super necessary, I could throw these on there while machining, and I could say, well, you know, within a couple thousandths I know where I am. And then if I had something like with the thread diameter, I always like to know precisely where I am. I like to take the major diameter of an external thread and go 1 to 2 thousandths below that. It's just preference. So if I needed to know precisely where I was, then I could take this and know that I could read it very close. This micrometer has readouts every 0.5 thousandth of an inch, but once you get experienced with knowing where the line is, you can really get to know these things and read them pretty well to 2 or 3 10,000ths of an inch, which is very precise. Ditto for the digital readout on these. If you're going to go relatively inexpensive, then I would not get a digital one. Definitely I've had some great digital micrometers like Starrett and Mitutoyo. Again, pretty expensive, and I just don't like the difficulties that digital instruments have when they're less expensive. One nice thing, though, is that with the micrometers, typically they're digital and analog, unlike the dial calipers where you only get one or the other. Most of the digital micrometers still read out accurately here if there's something wrong with the display. And I have one here that's kind of like not quite digital, but it does have a readout for, and this is not playing well with my lights, but you can see it reads out here to the 1,000th of an inch. But if I were going to take this literally, it's a couple 10,000ths off of this. So kind of like the dial caliper, this is something where you could use the counter on the outside to get pretty close to where you were going, and then you would want to double check with the readout on the micrometer itself. Now, because these can be sensitive to pressure, a lot of them do have, let me put this back on here. I find this a pain to use sometimes, but a lot of them do have an extra wheel up here that has a torque setting that will click at exactly the same pressure every time. So no matter who you give these to, if they use the torque setting, they'll get the same reading, whereas due to the differences in people's natural pressure, you can make these read differently too. And everybody kind of gets their own feel for their micrometers and has them set at their own way, but you really can get deviations that can be pretty important in precision machining. So if I do it right where it holds right there, I get 691 and a couple tenths. but I can easily torque it down another 7/10,000ths, which doesn't sound like a lot, but again, in precision machining, it is. On that note, most good micrometers have tungsten carbide tips on either end because most of what you're measuring is going to be steel or softer. So these won't deform if you're careful and you take care of them, but chips or anything like that can still get in there and deform the faces of these pads. And if you get a burr or a scratch or anything in there or deform them at all, then your micrometer is probably never going to read 100% accurate, or at the very least, you'll need it to be adjusted again. So like I was saying, these are precision instruments. You do want to be more careful with these because really good ones can be expensive, and because the precision has to be so high on these for them to perform their function. So that's really where you would use the dial caliper on a lot of the really quick and sometimes dirty measurements instead of something more sensitive. Now this is, as I said, an outside micrometer. This is a flat pad, but some of them do have different variations. There are some that are spiked, so you can read in valleys or divots or even at the bottom of threads. I've seen some that have a dome radius, so you can check the outside of curved parts. So there's all kinds of different, thin and wide, all kinds of different variations for these. And typically people who are career machinists, unless they're working at a really high-end shop that provides all of the equipment they need, and even then a lot of times out of preference they will get their own collection of tools. And I have a pretty small collection here. I didn't bring out all of mine. But one thing to note is that the outside micrometers are limited in a 1-inch range. So this is a 0 to 1 inch. You have a 1 to 2, a 2 to 3, 3 to 4. 90% of the time in gunsmithing, you'll be using a 0 to 1. I've used a 1 to 2 a handful of times, and to be honest, I don't remember the last time I ever used a 2 to 3 inch micrometer for gunsmithing. I'm sure there's a time and a reason out there, but when you're looking in terms of priorities and getting the things that you need, 0 to 1, 100%, I'd say get a micrometer. Even if you don't think you'll really be doing machining or anything like that, you may have to replace a pin or something with a tight dimension, and you're going to appreciate the extra precision on that. 1 to 2 is good to have. I would say if you can, go ahead and get a 1 to 2 with the 0 to 1. Beyond that, I wouldn't worry too much about it. Now, of course, someone's going to say, oh, I use mine all the time for X, but just in my experience. So moving on, we have another one right here. And this is a depth micrometer. So the depth micrometer has the same knurled handle and torque setting as the other one. And you'll see as I twist it, the probe extends in correlation with the handle. So as the name implies, this is measuring the depth of one reading to another. So this is a little difficult of an example, but... And by the way, I haven't explained this yet, I don't think, but this is a practice barrel that I made in gunsmithing school that we all made to practice cutting barrel tenons and threading and chambering and everything before we did it on expensive live barrel blanks. So it's threaded, I believe this is 1" 16 for Montana action, which is basically a Mauser. We'll check that in a second. And then I think this end out here is 5/8 24. And it's chambered in 30-06 to an action that actually is my 30-06 rifle, but I'm not pulling that apart to check this. But anyways, if you wanted to check the dimensions on the barrel tenon, that would be a great use for something like this. And again, that's something where you're going to appreciate the extra accuracy over the dial caliper. So I think this was supposed to be 750 plus nothing minus 5, if I remember my blueprints from 2 years ago correctly. So let's see how well I did. 7, 25, So I'm getting 742. So either I remembered wrong or I went a little short on this project. But that's very repeatable and very precise, whereas I can get a reading using this end of the caliper. Just now I got 745. So, this is much less stable, and especially with something like this, your angular distortion is going to affect it more. The depth micrometers, really I use them a lot when barreling actions, when you've taken the receiver apart and you're measuring, especially when you've trued it up on a lathe and it's maybe not what it would have been from the factory. You take this and put it on the face of the receiver and then measure down to the locking lug abutments and use that to figure out your barrel tenon length, things like that. Like I said, the dial caliper can be used for a lot of those kinds of measurements, but if you're going to be doing machining or, especially making custom barrels or anything, that's a good tool to have. Now, with that out of the way, just want to show you a couple projects that I made in gunsmithing school. So having precision measuring instruments allows you to make tools and gauges that are applicable to different jobs. So this is something that we machined from scratch. It was a required project, and it's a firing pin protrusion gauge. So when we have this completely closed, both the outside holder and the pin are supposed to be 900 thou in length exactly. And I'm getting 904 tenths. So, that little bit of variation. I do think I was within a tenth or two because I polished it down on a lapping stone to precisely where I need it to be. But this has sat over years, different temperature. The tools have sat a little bit. So, even if I went to another micrometer, it could be a couple tenths different. So that's a lot of what you're dealing with in precision measurement. But the idea here is you would put this over a firing pin that was exposed at its normal resting point, and then you would measure this, and you would know it's 900 thou when it's all closed up. Might have stuck that out a little far. That'd be popping primers all day. Trying to get a good protrusion. So, one of the things you check on a firearm is the protrusion for safety, and especially if it's acting up. And in this case, I've got 985 thousandths. So this one would have 85 thousandths of firing pin protrusion, which is pretty excessive. Typically, you'd look for about 50. So that's how you would use some of these other precision tools in manufacturing your own tools and gauges. And I'm sure something like this exists on the market too. This is a good tool to have. This is another one we made in school to practice hand shaping with files and things like that, so it wouldn't be super precise. This is just a shotgun cylinder gauge to tell you what the bore size is of the shotgun. Nice protractor angle measurement is good to have for anybody, any machinist or anything like that. That's the most common use I had for this, was to set my compound rest at different angles. You can use it for other things like checking the angle of stocks and things like that. You can use it with some success to check the inside angle of coned breech barrel tenons, of which some of the Winchesters come to mind, and some of the exotic custom actions today, like I think the, not the Montana, not the Bighorn, well, it's escaping me right now. Maybe it's a Defiance action. I think it's the Bat, maybe has a 60-degree cone face. But anyways, you could use something like that for checking it. Another great tool to have, which is inexpensive, is a feeler gauge set. So feeler gauges, they're used a lot in automotive work, and each of these corresponds with a different thickness that's precisely measured. I'm using a metric one here because I bought this from Germany when I was doing essentially a set me G3 build. So in that gun, it's a roller delayed blowback, and the bolt carrier group to the bolt spacing actually determines the amount of setback and the amount of recoil needed to unlock the gun. So it's very precise, and this is a good way to measure it. Another place where that comes into play is with revolvers. So this is my Bubba Special. This is probably the worst gun in my collection. I bought it for $35, half as a joke and half because I'd never seen anything like it, and I kind of thought it'd be funny to have in my collection as an example of what can go wrong when somebody modifies a gun at home. But today we're going to use it to show you how you can use feeler gauges to check the gap on a revolver. So two of the measurements that you would take on a revolver are the cylinder gap, which is the gap from the front of the cylinder to the rear of the barrel, and the end shake, so how much does the cylinder move back and forth. So this is where feeler gauges come in handy. 0.2 millimeters is a tight fit. I gotta think about that conversion. That's like 8 thousandths. Let's see what 0.25 does. The idea with feeler gauges is not to force them. So this 0.25 doesn't drop in there naturally, so I know that the gap is somewhere right around 0.2. Since it was a pretty good fit, I'd say it's about 0.2 to 0.22 millimeters, just guessing. And if I pull the cylinder back, the 0.25 just barely starts to fall in that gap. So I would say that the end shake is about 0.03 millimeters, so a thousandth or two. So it's really, even though it sounds like it plays back and forth a lot, there's really not a lot of movement. The Armenia's surprisingly solid gun when somebody's not done this to it. And the last measuring tool that I have for today, this is a thread pitch gauge. So I think I said the one on the back was 16. So I'm going to look for 16 TPI, which is right here, and see if I'm correct. So the thread pitch gauge has these little teeth. And the teeth correspond to the pitch on different threads. So each one of these is a different thread pitch. And then you put it up on the thread, looking at my monitor, seeing if that's going to focus at all. Yeah, it's a little difficult to see on there, but you get the idea. And this shows us that this is indeed 16 TPI. And I believe the other one was 24. So we'll check out here. It's not 24. I wonder if I left it on 16 and did like a 5/8 16. This is a good reason to have a thread gauge, not because I expect that you'll so frequently barrel your own guns and then forget what you just barreled them in, but, you know, something comes in with a pitch that you're not aware of, or you just want to check before you put an attachment on it. It's not 16. Not 18, might be 20. It is 20. Half 20. I don't know why I did it in that. That's a little strange. If I were going to do a half, most likely I'd do a 28. But what's done is done. This is a half 20 thread. So now if you got a barrel in that was threaded and you needed an attachment for it, there's a couple ways to do it. You can use a thread pitch gauge to check the pitch, and then use your caliper, figure out the major diameter, which is a couple thou under a half inch. So this is a 1/2" 20, so I know that's the device that I'll use. I can even throw my calipers on it. It's about 460 thou in depth, so I know if there's a shoulder on the muzzle device where it needs to go. The other way you can do that is you can get hardened thread gauges that are made in an assortment of common thread sizes, and then you could spin one on there and see which one fits. That's a quick way to do it, and that's a good way to check the depth of the threads to an appropriate, Class A, Class B, whatever fit. But there's some drawbacks to it. One of the big ones being if you get a pitch that's very close and it's wrong and you force it on there, the hardened gauge is going to destroy your threads that are there. So, it's good to have options. This is also great if you're working at a lathe and you're going to do your own threading, because threading is a nerve-wracking enough operation as it is on a manual machine, not so much on CNC. But when you go to cut the first line of the threads, there's all kinds of things that can go wrong, as simple as the machine will look like it's in one gear with the handle, but it's actually just hasn't caught yet, and it's either out of gear or it's in a slightly different gear. So you put your dicom on your outside diameter and you take a pass at about 1/1000th depth with the threading tool, and then you take your thread gauge and you line it up with the pass that you made and make sure that you're cutting the right thread pitch, because at that point if it's wrong you can still adjust it and there's no harm done, versus waiting until you get all the way done and then nothing fits on and you realize you've created entirely the wrong thread. So that's just a short introduction. With that said, probably a bit longer than I intended to go, but just an example of some of the measuring tools that you would use as a gunsmith, particularly one that's focused in machining. So I hope this video was educational to you and you took something away from it. If you want to see more content like this, do remember to subscribe, whether YouTube or Full30, and also check out the website potsprecision.com. That's where I do a lot of this type of content, with more written educational content in the works. So if you did enjoy this video, I hope to see you around for another one. Thank you.